Well, thank you to the class for being here and showing up. These are final, you kind of have to. And thank you for those of you at Trimet joining us. Great to have you here. We got a fun name going, Trimet Troublemakers Travel Map. And if you'd like to introduce yourselves.
I'm Vincent. I'm Max.
I'm Sophie.
I'm James.
And I'm Penny. And here's our pitch. So our Trimet travel map is taking like the big picture of the Trimet website and turning it local. Our mission is to create a user-centered website to aid short distance transit usage. This gets more people in public transit and less people in their cars, ultimately cutting carbon emissions in the Portland greater area. We accomplish this by making route comparisons and transit stop time schedules available manually in an intuitive way, visualizing Trimet's very own live data.
Okay. So just going to walk through some of the key features. We'll do a demo afterwards, but this is just a quick PowerPoint demo of it. So this is what it looks like when you boot it up. It's got a map of the greater Portland metro area, and it shows you all the various routes that Trimet offers, their various MAX lines and their various bus routes and stuff like that. So you can search for a known route or stop. So if you know a stop, say like on Willamette Boulevard, you can type that into our search bar in the stops tab, and you can select it. And then that brings up the various routes that are available for a given stop. And I'll go ahead and show that. And then you can select a stop for a given route. So if you can click on a stop, or you could also click on it on the map. There are little dots on the map. And it'll show you the various arrival times that buses or MAX lines are traveling through it. And yeah, it'll show you the times that those routes are arriving. And then also we have a few little about pages. So we have a service alerts tab that shows you the various service alerts for the various MAX lines or the various bus lines. We have a little about section and a little how to use section. All right, so now we're going to start talking a little bit about what's happening underneath the hood of this project. So Trimet has some servers that you can ask them for an app ID or a key, and they graciously gave us one. And that allows us to access some of their public resources that we can grab data from. So for example, I selected as a little bit of a demo to show y'all their arrivals function. So you can use their arrivals function. They give you all the information that you need to access it. And they show you all the various arguments that you can punch into that little function for the various information that you need. So the arrivals function, what this does is it shows you, if you give it a stop that you want to know what time the routes are passing through it, you can retrieve that information. And so this is what that looks like. So you can just type this into your URL, and we blocked out the section that says app ID because we don't want to share that with y'all. And it gives you can either return a JSON or an XML file. It gives you all that information. And we were able to parse that and use that for our app. Oh, also, Vincent, do you want to talk about the app ID real quick?
Oh yeah, it's funny that you covered it up. I mean, half of you already have heard this from us before, but the app ID, since it's placed directly in the URL, is not protected in the least, and you can steal it, no problem. I can go to Trimet's websites and in 10 seconds have their app ID. But we have our own. We didn't steal theirs. We did it legitimately, but that's fine.
Just wanted to cover our bases for that. All right. So this is just a brief code snippet of some of our fetching functions. Obviously, it's a little blurry, but we have some functions that basically recreate what I just showed you there with the URL. You can put in the URL, you put in the various arguments to your function, and it's going to produce you that XML or JSON file. All right.
Yeah. So when it comes to like static storing and fetching of data, it's kind of like how we run this through. So I did this for a JSON file for all the alerts, and that's a live data set. So that's going to actively be updating for whenever new alerts come out every time we refresh that window. To visualize all of TriMet's data, we have to first create a fast way of searching for the data points we need. We accomplish this by creating a data structure for transit stops, routes, and vehicles. We first pull an XML or a JSON file from TriMet's live data on launch or refresh, and then create an object for each route with its associated stops, times, the clickable buttons that we need to interact with, and everything else we need for it. Then we create a hash table and an ordered by ID table, one to easily quickly search for the specific data point, and one to list all the data points onto our info sidebar in an organized manner.
Okay, so just a little bit about, talking a little bit more about what's happening underneath the hood. So Penny covered what we primarily used throughout the project, which was static fetching, which is when the app boots up, we retrieve that info from the servers and we create a data structure in our program, which we constantly fetch from, or which we constantly retrieve the data from. So we're not constantly fetching from the Trimet servers. We actually did that earlier on in the project. As a matter of fact, every time the search bar would update, we would fetch more data, which is horrendously inefficient. There was one circumstance where we ended up using dynamic data or dynamic fetching, which is throughout the program, which is when we ever wanted to grab the arrival times from it. So a little bit more about what's happening with our program here is we had this sidebar, which showed you all of the stops and all of the routes. And we just created a list of buttons that had event listeners on them that would produce what information about wherever that button was. So if it's a stop, you click on the stop and it will recreate a list of tabs for you, a tab list of buttons that will show you what routes are passing through and what times they're arriving.
Yeah, so this is the service alerts that I mentioned before. It has to revisit them. Here you can see an example of the fuel alerts that were available at the time the screenshot was taken. And then you get the routes that are affected, the time at which the alert or detour is active, and a description given to us by Trimet. This is an example of parsing a JSON file from the Trimet servers. Each time this window is reopened or refreshed, we search for that data through our data sets that we've already established and created. And we parse that data into something that's human readable and easy for you to see and access.
So moving on, in terms of showing the stops on the map, we had to get something to work because there's about like 6,000 stops. So displaying them all, and when you zoom out especially, is very not ideal. Not only is it extremely slow, it just looks very unsatisfying. So what we went ahead and did is I went ahead and did some on-click listeners on the map. So starting off, zoom end will run this function that you can see below, which basically goes and checks the map zoom. And if it's at a certain zoom, in this case 15 is what we did. If it's below that, it will go ahead and go through every stop, and it'll get the lat and long markers, the latitude longitude markers. And if it's within the bounds of the map, it will display it. The reason we did this opposed to just showing them all if it's at that distance is it did get very slow because, like I said, there are 6,000 markers, and even if they're not in the frame at the time, it's still slow. So by doing this, and along with the drag end, which will go ahead and update every time a drag is stopped, it made it a lot faster and a lot easier to display these stops. The other one was the clicks, click events. Those ones, there was a problem when you would click on a stop. If it was at it'll zoom in on a stop when you click on it. And if it was at that zoom and you clicked on another stop, it would not get rid of the other stops. And so the reason the click event is there is just to update whenever there's a click on the map, in this case on the stop specifically, which ended up working out and fixing the problem. So moving on into looking at clicking on a stop and clicking on a route, more so in the side table. So when you click on a stop, stops are pretty easy to set up on centering. You just go ahead and get the longitude, latitude, and center the map on said longitude and latitude. Leaflet, the program you're using, has a very nice feature for just centering on a specific location. With the routes, it was a little more complicated, but still not too hard. What we did for that one was go through the polylines for every single polyline for a given route and add those into these bounds. In this case, I use bounds.extend, which goes ahead and takes the latitude, longitude of the map at a given location. And we'll go ahead and just keep extending that if it goes outside of that. So by doing that, we were able to get it to display the entire route and all the stops on said route in a good fashion.
Yeah, and then something that I was really proud of implementing was live transport locations. So we have these bus icons that are on the map. They move according to where the bus is currently situated. That is data that we are fetching from Trimet. And it will also tell you when you hover your mouse over that bus, what bus it is and what its next stop is going to be. So the code for that was relatively straightforward. We wanted to show which buses were on routes that you have selected. So we didn't show all the buses at the same time, kind of for the same reason that we don't show all the stops at the same time. We enabled pop-ups, and then we also had a function that would allow us to push everything to an array. So we could have all of the markers there and then remove them so that you wouldn't see a trail of buses and all of the shadows of the past.
All right, now that they've covered all the interesting stuff, I get all the boring stuff like testing. So testing kind of stinks for front end things because there's not too much you can test. So we did not have very many tests, not very good code coverage. We tested primarily our fetching functions. It did do something. We caught a regression or two because we modified the fetching because we do so much of it multiple times throughout our coding. We probably could have done some testing to test, like take some sample data from Trimet and test based on the sample data. But by the time we were around that point, we didn't have enough time. So, and then the tools we used, pretty standard, pretty simple. We used Node.js, of course, with Express. And of course, since it's a web browser, we use JavaScript. Go figure. jQuery is not on here, but we use jQuery. Leaflet was our map API, a very nice one indeed. And then, of course, Trimet's data.
All right, so a couple things we want to do differently. This is just basic stuff and more team management things. Communicating to each other when we need help. Meeting times was another big thing that we talked about. We set our meetings on the same day that we had class, which meant that we weren't motivated to really meet again because we're like, oh, we met in class that day. Skill sharing, so that's more a communication thing about like, I learned how to do this and this is what I put in the code today. I want to show everyone else how to do it. Planning is something we also wanted to deal with, and code quality because we ended up having to refactor pretty early on in the project because we simply didn't think out far enough ahead and had to change up what we were working on. In terms of the SRS that we wrote earlier this semester, we had some great objectives that we met that you can see functioning on our app. We have multiple buses are able to be selected at the same time. You can zoom on the map. You can compare multiple bus routes. You can check the service alerts, as Penny showed us. And we also have fast and accurate fetching. And also our fetching speed depends on what data we're getting. So for example, our buses update the fastest, our stops and alerts do not update as quickly. We do have some additional features that we wanted to add. We wanted to be able to, you'll see this function in a demo, but we're able to pin routes, but it's not very intuitive. It takes a couple of clicks. It's not currently colorblind accessible. We currently only have one transit icon for every type of transit. And the biggest thing is we don't have a trip planner, which was something that we really wanted. So you can't put in your location and then put in a destination and it won't generate a route for you. If we have time, Dr. Triplehorn, I don't want to take up too many other presenters' times. Okay. I'm going to jump to our demo then, if possible. Okay. So this is our site. Is it still visible on Zoom? Awesome. So this is what it looks like when you load in. You can go ahead and search for a route. Our favorite, because we're biased, is the 35, because that's the one that services the University of Portland. You can click in here, you automatically see all these buses populate. It will tell you what the next stop is. You can zoom in and hover on a particular stop. It will give you which stop that is. When you click on that, you can find routes that go through there as well as arrival times and things like that. Another advantage of our app is we're able to pin various stops. I take the 35 a lot. The 44 is also one of my favorite stops. They both lead downtown. So you're able to pin both of these and you can see the differences between them. Also, when you hover on a route, it will tell you which route it is so you don't get too confused. And as you zoom in, we wanted to make sure that you could differentiate what was a stop for that particular bus route. So we colored them and put them in a nice black border. We also have a function where if you click on the Trimet travel map link, it will refresh the page for you. How to, quick guide. We have our service alerts here, all lined up in a table. We have our about page. This links to the Trimet website where you can find the official Trimet travel planner and also the data APIs that we used. You can also, as seen before, search by stops if you want to look at Willamette, for example, and you can see a variety of them. Click on them and get the info that you need. Am I missing anything there? Yeah. All right. So that's what we have for you. There's also a video for the people who have access to the presentation if you want to watch a video of us going through all of the features again. But that's it. Thank you. Should I stop?
So with this video, I was wondering, does the API have any functions not related to data fetching, like push data? But I was just wondering, because I assume this information is all public. I guess like in defense of Trimet, like I think it doesn't matter.
Yeah, pretty much, but they required it anyway.
You could just like write a, you could just scrape the page.
Well, yeah, but we didn't want to just go and steal their app ID. We're responsible people.
And it was pretty simple to get it. We just filled out a quick form, took like 2-3 minutes, if that, to fill out, and they got back to us in a couple of days.
You guys mentioned a lot of like user, like getting rid of stops when you're zoomed in, so it's like part of the screen. Does this mean that when you're zoomed out, it's slow?
No, so when you're zoomed out, so do you mind if I
Yeah,
take over?
please.
So when so this is what it looks like when you're zoomed out. There's no stops. And as you can see, it's pretty fast. We also have bounds on the map to make sure you can't leave the Portland area. So when you zoom in, it only shows stops at that zoom. So moving around, it's still just as fast. There's no latency issues or anything for that reason.
Yeah.
I can see that you're using like a local host. Were you able to like push your apps like being used elsewhere? Or is it only on local?
We could, our app hardly uses NPM at all. We use it basically for testing but the HTML file, you could actually just dump the HTML and JavaScript files on a static site and it would work perfectly fine. We didn't do it because we're not doing it for a client, so we didn't really need to deploy, but it would be pretty easy to. It would be easier than basically anyone else's project to deploy.
Yeah, we're not pushing to a data set, and we don't really just pulling data and visualizing it. So it's pretty simple just to port that over to whatever streaming source there is.
Yes.
You're gonna get starter code. Like, what did you first get started on this project?
Yeah, so we had 0 starter code. This was pretty much from scratch. We had like our homework assignments that we knew how to use Express with NPM, and we of course learned JavaScript to jQuery. But
And Leaflet was really helpful too. That was nice.
yes, we
scaffolding
had
for us.
Leaflet. We did some research on
Which of course is
what-
our map API that allowed us to, do all the map stuff.
Yes, of course. We did some research on what kind of tools to use, like we're using Leaflet and such. We looked at what the GTFS, what geospatial like system that Trimet was using as well, and we're looking to what made sense for the scale that we were going for and what was easier to work with. But we started from a blank slate.
Cool.
All right, and thank you folks from Trimet for coming. I'm gonna
They have some stuff in the chat, by the way.
jump off the Zoom.
Check the chat.
Okay.